Section 4.4, absolute minimum and absolute maximum. Alright, so what we're going to be looking at here, we looked at relative max, relative min. Now we're going to look at what is the absolute max. For example, let's suppose we have a graph that does this. No, we'll have to do this. Alright, so this graph has relative max, relative max, relative max here, right? But the absolute max is this one right here because it's the absolute highest. Now this graph has no absolute minimum because it goes down forever here, down forever there. So you can't find a number where it has a minimum. But what if I restrict this graph from here to say right here? Then it has an absolute, if I'm only looking within this interval from here to here, it has an absolute minimum here. This is the relative minimum. That's the absolute lowest value that my graph takes on. Alright, so what we're going to look at first is on a closed finite interval, a function that is continuous, okay? So what does that mean? That means, let's suppose I have a closed interval from A to B like this. It have a function that is continuous on that interval. So I could have a function that does something like this. Goes down, goes up, goes down, goes up, and goes down again like that. Alright, I could also have something that looks like this. On the closed interval from A to B, I could have a function that does like this, that, goes down like that, and then like this, okay? Alright, let's take this case. I have an absolute maximum right here, an absolute minimum right there on that closed interval from A to B. How about right here? Yeah, I have a minimum here, a minimum there, but here's my absolute minimum. Here's the absolute lowest value my graph takes on between A and B. Here I have an absolute maximum. Yeah, here's a maximum, but the absolute or the highest value is right here. And the maximum will be whatever this y value is right here. This minimum will be whatever that y value is there. But the point is, if I have a continuous function on a closed interval like this, a to b, where can my absolute max and min occur? This example it occurred right here, right? At what? A critical point, right? Because that's where my derivative was equal to 0. Right here, my absolute min occurred at a critical point where my derivative was equal to 0. Here, where did my maximum occur? It occurred at this end point, right? Here, where did my absolute min occur? At the end point. So if I have a continuous function on a closed interval, where's my absolute max and min going to occur? At the end points or at the critical points, okay? And actually, in your notes, you have a procedure for finding the absolute max and min on a closed interval. It basically says this. If you have a closed interval from A to B, what you do is you find all your critical points, find all the values where your derivative is 0 or undefined, and you evaluate your function at each one of those critical points, and also evaluate your function at the endpoints. And whatever comes out to the highest value is your absolute max. Whatever comes out as your lowest value is your absolute min. Well, I could talk all day about that, but talk is cheap. Let's work some examples that really cements this stuff in for you. Alright, so page 2 of our notes. We have an example, and this example reads, find the absolute maximum and minimal values of f on the given closed interval and state where those values occur. Alright, so we have f of x is equal to 29x minus 58 sine of x, and then we have the closed interval from negative pi over 4 to pi over 2 like this. Alright, so they want to know what are the absolute max and mins and where they occur. Let's say, for example, I have a graph that does something like this, okay? I have a graph that does something like this, and I'm looking from this value to this value, from A to B, okay? Here's an absolute min, and let's say that this is a point 3 comma negative 2. I would say the absolute min is the y coordinate, or the output, and the absolute absolute min is negative 2, the y coordinate, and I would say it occurs at the x coordinate, or the input value, 3. So in other words, let's say that's the absolute max. It occurs right there, okay? And let's say that's a point negative 1 comma, I don't know, maybe 3, okay? I know this is not drawn to scale or whatever. Okay, let's just say this. Let's just say it occurs at negative 2 comma 2, okay? Then I would say my absolute max is 2, the output, and it occurs at negative 2. So basically your y coordinate is the actual max or min. It occurs at the x coordinate. Alright, so let's find the absolute max and min and where it occurs here. Well, what do I have? I have a function that's continuous on a closed interval, right? So what do? I find the critical points, evaluate the function at the critical points, and evaluate the function at each one of these endpoints. The highest value, absolute max. Lowest value, absolute min. Alright, so let's find the critical points. Let's find f prime of x. Have you noticed pretty much everything we've done since the last quiz, we're taking a derivative? So in this quiz, when in doubt, take a derivative. At least go that far. And see if it, ignites your memory. Alright, let's take a derivative. We have 29 minus 58 cosine of x. There's my derivative. Now let's find out where this derivative is equal to 0. So 29 minus 58 cosine of x, let's see where that's equal to 0. And where it's undefined. Well, this function is not going to be undefined anywhere. So I'm only looking for my derivative is 0. So I get negative 58 cosine of x is equal to negative 29. Or I get the cosine of x is equal to 29 over 58. Or the cosine of x is equal to 1/2. So now let's solve for x. Where do I have values where the cosine is 1/2? Think about your unit circle again, okay? Where is the cosine 1/2? The cosine is 1/2 at pi over 3. X is equal to, how about cosine, think about the unit circle. Let me go ahead and draw it here so I can point to it, okay? Alright, so we said at pi over 3, my cosine value was 1/2, right? What about over in this quadrant that we're referencing on pi over 3? Isn't my cosine 1/2 there? Now, which angle is this? It is 2 pi back off pi over 3, right? 2 pi minus pi over 3. Well, what does that give you? 5 pi over 3? Pi over 3. Now I have to be careful here, okay? I'm only looking in the interval for negative pi over 4 to pi over 2. This is what, like 1 2/3 of a pi? So that falls way outside that range. So I do not use this value, okay? Are there any other values between negative pi over 4 and pi over 2 where my cosine is equal to 1/2? No, only pi over 3. So pi over 3 is my only critical point in this interval. Alright, so what do I do now? We say we evaluate our original function at pi over 3, and we evaluate our original function at each one of these endpoints, okay? So let's look at f evaluated at pi over 3. That'll be 29 times pi over 3, 29 times pi over 3 minus 58 times the sine of pi over 3. So that's 29 times pi over 3, or I could say 29 pi over 3 if I wanted to, minus 58. Well, what's the sine of pi over 3? The sine of pi over 3 is square root of 3 over 2. So now if I go ahead and simplify this, I get 29 pi over 3 minus, what is that, 29 square roots of 3, right? So that's f at pi over 3. Let's evaluate f at now this endpoint, negative pi over 4. So f evaluated at negative pi over 4 will be equal to 29 times negative pi over 4, 29 times negative pi over 4, minus 58 sine of negative pi over 4. All right, so this gives me negative 29 pi over 4 minus 58. And what's the sign at negative pi over 4? Negative square root of 2 over 2. So that gives me negative 29 pi over 4 plus 29 square roots of 2 if I simplify that. Now let's evaluate f at this other endpoint. F evaluated at pi over 2. So that would be 29 times pi over 2 minus 58 sine of pi over 2. So 29 times pi over 2 minus 58 times the sine of pi over 2. So that gives me 29 pi over 2 minus 58. And what is the sine at pi over 2? That's just 1, right? Well, 1 times 58 will give me still what? 58. All right, so I found the critical points. I evaluated f at this critical point. I evaluated f at each one of these endpoints. Now I have to determine which one's the greatest and which one's the least. Well, I might need a calculator to help me out with this, okay? And if I plug this into my calculator, what was that one? F at pi over 3. I got approximately negative 19.86. And this value, negative 29 pi over 4 plus 29 square roots of 2, I got approximately 18.24 when I put that into the calculator. And then for this one, f at pi over 2, I got approximately negative 12.44. All right, so what am I looking for here? I'm looking for the absolute max and absolute min. So my absolute max, I'm going to have an absolute max of, what's the greatest output here? Negative 12.44, 18.24, or negative 19.86? 18.24, right? So that's going to be my max. But I want the exact value. This is rounded. I want this exact value for my absolute max. My absolute max is going to be 29 pi over 4 plus 29 square roots of 2. And it occurs where? Occurs at, remember, it occurs at the x or the input value. What was the input value for that number? What did I input? Negative pi over 4. How about my absolute min? I have an absolute min of what? I would say this negative 19.86 is the least output. But its exact value is this right here, right? So I have an absolute min of 29 pi over 3 minus 29 square roots of 3. And it occurs at the x value or the input value of what? Pi over 3. All right, big picture. what we do? We had a closed interval like this. We found what? The critical points in the interval, evaluated my original function at that critical point, and the original function at each one of these endpoints. Which one was the max? Is the highest? Which one's the min? Is the lowest value?